Hello, this is Bobby at Copel TV Repair with a quick how to test video that will also serve as a functionality proof for the customer who ordered and will receive that board from us. This is a used board from Vizio E700i. As you can see here, dash A3. The number of the board is 09-70 000-00. I'm trying to see whether that is. It's probably going to be here on the label. Yep. And that is actually a more accurate leading number than the PCB number that's printed on the board. Many different boards can have different PCB numbers, but depending on the assembly, on the components that are put on the board, they may have a different final number and sometimes may not be compatible with each other. Usually the numbers that are on the labels should be the leading numbers in regards to reference as to what you need. I have done other videos for Vizio mainboards from that generation. It's a pretty old generation, and this video probably comes 10 or so years too late. Sorry about that. Hey, better late than never. The very first thing that you want to see when you take the board out is those three capacitors down there to see whether they are puffed. A lot of people will tell you that you shouldn't be leading by whether they are puffed or not. You should be using an ESR meter. And if you have an ESR meter in your household or shop, absolutely use an ESR meter. But most laymen will not have an ESR meter, and honestly most people will not need. Look on both sides, front and back, and if you see signs of puffing, you need to replace those. You can find them all over the place. We may be selling them. If we don't, then I'm sure tons of other people will. That is the very first thing you want to do. The second, you should check the fuse if you can with a meter. If you don't have a meter, unlike ESR meter, I strongly urge you do invest $10-20, as I have said many times in my videos. Just go and buy a multimeter. You're going to use it for your car, you're going to use it for your equipment, you're going to use it for your TV. Eventually your AC conditioner will fail, eventually maybe your fridge will fail, eventually the washer dryer will burn a heater element. You're going to test that. A gazillion uses. So if you don't, go and do it and test that fuse. More often than not, with those boards, the fuse will be good, but anything happens and the fuse is one of the very first things you want to check. If the fuse is bad, the board is going to be bad. Now, if both of those things pass okay and you still don't know whether the problem is in this board or something else in that TV, and you want to narrow down your choices by troubleshooting and see whether the board works, this is what you need to do. You want to make sure that this board out of the TV as it is here, or with nothing connected to it, will be behaving as it's supposed to be, which means it will be producing standby voltage, and when it's told by supposedly the main board that is connected to it, it actually activates the various circuits and outputs the voltages that it's supposed to. I have it here on a bench, and it's up there, and what is of interest to us is that connector here with all the meanings that its pins have. As you can see, it has a 3.3 volts, which is its standby. That's what it should be producing without anything attached to it. So if you can measure again with that same device that you use for the fuse to measure 3.3 volts here compared to the ground, which will be, well, one of those pins as well, or very often it will be something like that. But don't always count to that, because sometimes they might not be. Those are on the primary side and they may or may not be equal to those same grounds. But other pins here will be ground, like right to left, 1, 2, 3, 4, 5, 6, 7 pins from right to left are ground. So any one of them to the very first pin, the yellow wire here, will be 3.3 volts. And that's what you should have when you connect the power. However, on many Vizio boards from that generation, this voltage may not be quite stable. And the voltage that will have to come after it may also not be quite stable. And by what I mean by after it is when you activate the power board. And what that means is that you send those 3.3 volts. This is what the main board does when you turn on the TV. It sends those 3.3 volts to the pin called PS on, which in turn tell the power supply to first turn on something that is called a power factor correction circuit, which makes from the 160 volts normally found all over the mains filter capacitors, it activates a circuit. It's actually this circuit here. And actually I might be wrong looking at those. It's this circuit here, my bad. And the reason I'm confused is because near to that is something that goes over the line to the secondary, and here and the one here there is something that's common to the secondary. So if I have to guess, because of that, what is that? That is the major rectifier. Well, it's one of those two. Oh, it's this one. So this circuit is for that transformer. Those two power switches are for this transformer, and these are the one that in connection with that coil and these diodes will be boosting the voltages, that's the power factor corrections here, to nearly 400 volts. So when you connect and when you activate the board, sending 3.3 here with a jumper to the PS on, you should be reading 400 DC over those. And also you should get a bunch of output voltages, like the 12 volt regular here. The T-cone voltage will not be there if there is a LED activation. There is no LED activation. I don't see the 12 volt audio should be there too on that board. But here is the thing. Some boards do require that there is a load on them. Otherwise, they may behave erratically. And what I have here on this connector, which is originally made for M70C3, but they do have, because they are from the same generation, the outputs are the same. I do have a resistor that is 22 ohms. First of all, I have a jumper that signals, you see the jumper on the left side, that basically signals, which means shorts the second and the third pin. The second is AC detect. And AC detect is a voltage output that is basically sent by the power supply board to the main board that senses whether the board is connected to AC. And it's also close to 3.3 volts, so it many times it might be used. And that's what I use here to do two things at once. Ensure that AC detect is there, and then send it to PSON to actually activate the power board. So the first thing is I just have a jumper that does that. And the second thing, I have this 22 ohm resistor. I would put something slightly higher because this overheats a lot, but that's what I had handy, and that is what I put. That puts 12 volts regular to the ground. Without that resistor, that board will behave erratically. You will read erratical values for voltages, and you will be doubting whether the board works or not. This takes some time to find out because many boards don't have that problem. These generation of Vizios do require that in order for it to behave properly. And when you do all of those things and you plug in power, which is what I'm doing right now without you seeing it, what you have here at the output of that resistor is 12 volts stable. Without the resistor, it will not be stable. You will also be having 400 volts here, which I can show you. Nick commended me for my one-handed use of the pins. And one day I may invest in a better unit, but for the time being, I'm just too lazy. So here's what you have on the 400 volt side. 350. Okay, this board, but it's stable. This board goes to 350. The floating that you saw at the end was because of my unsteady hands, of course, being near 400. Most of the times this voltage will be around closer to 400. I am guessing that it's probably because of this load. It needs something more, but it will maybe raise more than that, maybe 360, 370. But whatever it is, those two are quite enough to tell you that this board is working. First, it raises the PFC and it's stable. 350 is generally low for PFC, but it's absolutely doable. This is not a heavy power TV. They may raise it to 350, they may raise it to 360. It's fine. On most boards, it will be closer to 360, 380. On some, it can go as high as 400. That is the one very common thing you need, and the other is the output of those. Usually, if you have stable voltage for one of the secondary circuits, and this is the 12 volts in this case, the others will be stable too. Why? Well, because they come from the same transformer. If one of them has a problem, it will affect all others. One thing that we did not check here is the output of the LED driver. It's a little bit trickier to test, and it suffices to say, it's not impossible, but it's trickier. It really depends on the board. Suffice to say that there is a 99.9% chance that there is no problem here. In all the boards that we have seen in this Vizio generation, there's just no problems, and LED drivers rarely ever go bad. LEDs go bad before them. So what I showed you is clearly not 100% functionality proof, but it definitely covers, let me use a new term that I learned recently, the sensitivity of this test is, I would say, 99 and higher percent. So 99% of the time when we're finding those, we would have probably identified a board that is working fine. And that's it. Hope you learned something new. And we're sending this board to a buyer who received it. This is unique mark. This is how they will sell it. Best of luck with your repairs.